it's a really great joy to be in the satellite industry these days. So I think I will use the SkyEdge-4, which we launched last year, as the example of what's new and innovative in ground systems. Let's start with the tagline we gave to SkyEdge-4, which is ground space harmony. And I think that tells a lot about the system. I think the system is very innovative in the fact that, as my colleague from HNS said, the satellites are changing. They're becoming very flexible, and therefore the ground system had to change completely in order to accommodate that. Okay, let's go to the next slide and see how what is the reason that how do you do it? How do you do the ground space harmony? Let's call it this way. So if you look on the right side, which it is more clear, you can see an orchestrator, and you see the elastic total NMS of the SkyEdge-4. That's one important thing to do. The multi-orbit constellation like MEO, for example, Empower of SES, that we are providing the ground system, is a very flexible software-defined satellite. It has a resource manager that is orchestrating and communicating with the new system in the ground. So first thing to do is really to provide a good interface and a good responsiveness to satellites that are changing orbit, changing power, changing locations of beam, put beams on and off in a dynamic manner, things that they were not done before, and the SkyEdge-4 is doing that, and actually we are going to launch it with SES very soon, and it will be the most advanced, I think, software-defined satellite in the sky this year. The other thing that is important is the way to define the system to be cloud-based. Let's move to the next slide. I think I will go over all the vectors that are important because it is difficult to see the text. So let's move to the next slide. Good. So there are few vectors that I would like to discuss. So the first one is to move to the cloud. You can see the virtualized data center. So the system needs to be architected for the cloud from the beginning. It's impossible to move to the cloud after you have a system that was not defined to that. And the SkyEdge-4 is a system that most of the operations that are done in software. Hardware is very, very strong. So once you put the hardware, the only thing that you need to do is to configure software, open virtual machines, and so forth. The other thing is the scalability, the higher density. When the new satellites like Empower and the new VHTS coming to the sky, they are coming with between 10 to 100 times more capacity. The systems of the past, they cannot handle this capacity, and they must be much more dense. Just to give you an example, our multi-channel receiver is like nearly 20 times more wide than the receiver that we had in the system, the SkyEdge-2C, that is a very competitive system compared to what is going on. But we are doing 20 times more wide receiver. We can handle hundreds of gigabits per second without much changes in the hardware. Accordingly, the terminal should be very high performance. You need to go with a single terminal. You need to handle speeds of gigabits per second rather than tens of megabits or hundreds of megabits. So you go 10 times more on the ground terminals. Accordingly, the packets per second that you need to handle are there. Although we are talking hundreds of megabits today, we want to go to gigabits with this system. And And the last thing that is important is how to interface to standard orchestrators, and that's one of the things we invested in the management system. Let's go to the next slide. Here in this next slide, there is an illustration of how you do it correctly in order to be architected for the cloud. So as you see, the data center is mainly logically is with virtual machines, where you each virtual machine can be attached to a different gateway, and that's how. And on the northbound interface, you go to an infrastructure that is standard, like standard orchestrators. That means that satellite operators can use the cloud environment that they want to use in their operations, also with SkyEdge IV. The end result of that is that even if you are not using cloud today, you have a cloud evolution in the future. You don't need to go with a completely new system, greenfield. You can use the SkyEdge IV that is already doing the job for you on the software-defined satellites, and move it to the cloud in the pace and in the functionality that you want. Let's go to the next slide. So you can see something here that is very important on the SkyEdge IV. The SkyEdge IV is actually supporting VSATs of the older generation, the SkyEdge 2C. As you know, we are leaders in cellular backhaul, in-flight connectivity, and these VSATs for the cellular backhaul and the IFC will run also on the SkyEdge IV. And then we added the Aquarius family, which is a gigabits per second family. So you actually have the satellite operators, service providers will be able to leverage the fact that they have already existing platform and VSATs that are installed, and they can run on the new system as well, providing even higher speeds and packets per second than before, because we improved the architecture. So if that's not enough, we also introduced, because of that, a new access scheme. Can you go to the next slide, please? So this new access scheme, we call it Elastic Access, and it's called XDC. It's a completely new access scheme in the upload channel in the inbound, and it provides return speeds of 750 megabits per second with a 250 megasymbols per second channel. These are very important for the cruise services, for the maritime, and we also develop what we call elastic dense coding, which is 15% superior to standard LDPC. That is currently the best the best scheme that people are using in the return channel, and it is also working with the widest dynamic operation and SNR. And as my colleague from HNS said, it's all automatically done. You just provide the software and the frequencies, and you provide the range of mode codes, and the system is doing it for you automatically. So altogether, these are the I guess the SkyEdge IV, which is now already operational, is providing everything is new. The network management is new. It's the first system that is doing multi-orbit today, GEO and MEO, and also architected for the cloud. And I guess these are the important things that I wanted to tell about innovation. It's not just slides. The system is already deployed all around the world, and will be kicked off in its biggest, let's say, instance with Empower, hopefully very, very soon. So